Get it? A bear playing drums on logarithms. Wah, wah, wah. Logarithms. Okay, so again, if you don't have this changing this log base b of x equals y is the same as b to the y power equals x written down, you should write it down because it is the crux of solving exponential equations and solving logarithmic equations. If you have a logarithmic equation, you're going to put it in exponential form to solve it. If you have an exponential equation, you're going to put it in logarithmic form to solve it. So it is the crux of what we have to do today. So if you don't have that memorized yet, or don't have it written down, please take the time now to write it down and then get to know it. Okay. So, how do I want this? You gotta have whatever it is, logarithmic part or exponential part. You gotta have that completely and totally isolated so that it looks exactly like either one of those two. Okay? There can't be anything after, before, below, or above. Okay? Totally isolated in order to do these. So, for instance, in this one, I would first divide by 4 on both sides. When I divide by 4 on this left side, the 4's cancel each other out, gone, leaves me with 3 to the x over 2 power equals 27. Big brain. Then, now that you've got it isolated, now you can, in this particular case, we could write them both as base 3, because 27 is 3 cubed, but that's not always going to be the case. So I'm not going to teach you that method, okay? Whereas I'm going to teach you okay, so now we take this equation, this exponential equation, and we have to put it in logarithmic form. So now it becomes the log, my base is 3, of my argument, 27, equals my exponent, x over 2. In this case, it works out nice because there is an exponent that we can put on 3 to get 27. If it didn't work out, if this were 28 here, let's say, then we'd have to use that change of base formula that we talked about last week. Or I should say, excuse me, earlier this week we were talking about properties of logs. Okay? So we'd have to do that. In this case, what exponent do I put on 3 to get 3? Or excuse me, what exponent do I put on 3 to get 27? 3. So this is 3 here equals x over 2. So x has to be 6. Quick check. 6 divided by 2 is 3. 3 cubed is 27. 27 times 4 is 108. Okay? When you have multiple logs, you need to so when you have multiple logs, if you've got 2 logs of the same base, okay, then you can get them in log equals log form, and then you can just set argument equals argument. If you have 3 or more, you first have to combine them into log equals log form. So that is because this right here is an addition sign, that's product property. So this would become natural log of x minus 3 times x plus 4. This one over here would become power property. So this would become the natural log of 2 cubed, which is 8. Now we're in that log equals log case with the same base. They both have base e. So this one would actually be natural log of 2 cubed. So now that I'm in log equals log form, now I can take argument has to equal argument. So we can say x minus 3 times x plus 4 equals 8. Double distribute x squared plus 4x minus 3x would be plus x minus 12 equals 8. Subtract 8 from both sides. X squared plus x minus 20 equals 0. Two numbers that multiply together to be negative 20, yet add to be positive 1. 5 and negative 4. Yes? Going back and checking them, so my answers were negative 5 and positive 4, right? If I plug negative 5 into the first term, I get the natural log of negative 8. Yes?
Right.
Why can't I do it? Can't have a negative argument. Yep. So negative 5 gets rejected. Just based off of that. Okay? Thrown out. It's extraneous. Okay? If I plug in 4, I get the natural log of 1 plus the natural log of 8, right? Equals the natural log of 8. Applying the power property, right? What's the natural log of 1? 0. Because what exponent do I have to put on e to get 1? 0. Okay, so that 0 is the natural log of 8 equal to the natural log of 8. Yep. So my only answer here then is 4. Negative 5 got kicked out. Okay. Positive arguments only. No negativity. Solving a logistic. Now we want to solve this one for x. Okay. Now, in the mathematical world, we really consider this over 1, right? And so what we would do is we do a little term called cross multiplication, right? Okay. Or multiply both sides by the quantity 1 plus 25 times e to the 0.3 x power. Okay, so we do that, right? Okay. Well, that is the same thing as doing this. I can just flip-flop those. These, because they're on the same diagonal in the cross multiplication, I can flip-flop them. Because that's what we would have done. The long way, we would have done, okay, so it would have been 500 equals 200 times 1 plus 25 e to the 0.3 x power. Then we would have divided both sides by 200. And we would have been in that spot. And which is why we can do that. Okay. 500 divided by 200 is just 5 halves. So now, ladies and gentlemen, I have this e term right here. That's what I need isolated. Okay? So how am I going to isolate that? Subtract 1. Except on this, so on the right side I'm going to subtract 1, but on the left side I'm going to subtract 2 over 2. So now that gives me, let me scroll down here just a wee bit. So that now gives me 3 halves equals 25 e to the 0.3 x power. Now what? Divide by 25 on the right side, but that's really what? Multiplying by what? 1/25 after we keep change flip. Okay? And so that's really multiplying by 1/25. So now I've got 3 over 50 equals e to the 0.3 x power. Now I've got my purple box isolated, right? Okay. So now I can switch forms with it. We're in exponential form, so I need to go log base e. What's log base e? Natural log. Okay, so I've got the natural log base e, of 3 over 50 equals 0.3 x. Now here is where you should go to, because this one, I don't have a nice number that can go, that I can exponent I can put on e to get me 3 over 50. So now here we can go to our calculator, and we can say the natural log of 3 divided by 50 is, and on my calculator, I got negative 2.81341017. But I'm going to leave that on my calculator. I'm not going to touch it. I'll leave it on there. Okay? Now, what's my next mathematical step? Divide by 0.3, right? Okay? So on my calculator, without doing anything, literally divide 0.3 equals. And I get, here now, I got to extend my page just a little bit. Divide by 0.3, divide by 0.3, and I get negative 9.378035723 equals x. Now, the normal convention for us in these type of problems is 3 decimal places. So we would accept here as an answer negative 9.378. Because that is not the argument. That is the x in the exponent. And we can have negative exponents. Hate to break it to you, but in life, not everything's positive. It's not all unicorns and rainbows.
So if that's negative Does that make this logistic function a decay?
No, it makes this a logistic growth because, well, first off, it's negative because, I'm sorry, yes, because this up here was positive. That makes this a logistic growth, which makes this a logistic decay. It's all about it's a reverse thinking of the exponential part in a logistic. So because the logistic or the exponential part here was growth, then the logistic is a decay. If this is an exponential decay, then it's a logistic growth. It's funky reverse thinking. Okay. You try that. Solve the perhaps. Okay. So first off, I'm going to divide both sides by 4. So that's going to give me 3/2 to the 2x minus 3 power equals 17 over 4. Yes? And I've isolated my exponential term, so now I can shift it into logarithmic. So this would be log base 3/2 of 17/4 equals 2x minus 3. Now, we can figure that out, okay? But we're probably going to have to use, if we're using these wonderful TI-30X2S's, okay? We can still figure it out. If we're using a more sophisticated type calculator, it figures it out for us, okay? So we can go, we have to do a little change of base over here, okay? Because it's all about the base, about that base, about that base, okay? No trouble. We can go log of 17/4 divided by log of 3/2. Now, if you're using one of these TIs, the scientific one, make sure you're closing your parentheses after the 4 and after the 2. So it would be log of 17 divided by 4, close parentheses, divided by log of 3 divided by 2, close parentheses. And I get 3.56854127. Okay? Again, going to leave that on my calculator as is because I've got some more work to do with it. Oops, I put +3, that should be -3. In my brain, I was already thinking about my next step. So then I'm going to add 3. Going to do it right on my calculator. Okay. Then I'm going to, right away on my calculator, I'm going to divide both sides by 2. Because I'm doing all of that on my calculator. Divide by 2. Now I get 3.284270649 equals x. And so I would say here 3.284 is x. How you go about checking that? Well, you can go back up here to the original problem and you can go times 2 on your x minus 3 on your calculator, and then you can take 1.5 raised to that power, and I get 4.25, multiply that by 4, and I get 17. Okay? If I use the rounded one, I would get close to 17, and I know I'd be okay if I was close in that range.